In this video, we will learn how to use Matplotlib to plot graph in Python using both functional and object-oriented methods. Then we will see how to adjust other attributes such as figure size, colors, axis range, line width, line style, and marker styles, along with adding legends to the figure and saving that figure in different formats. If you are working with data in Python, you would most likely use Seaborn or Pandas built-in capabilities to plot graph to quickly visualize and analyze the data. However, knowing the basics of Matplotlib would allow you to customize those plots as per your needs. Before using Matplotlib, we would need to install the Matplotlib package in our system. If you are using Anaconda distribution system, then you can install it using conda install matplotlib command in your Anaconda prompt. Otherwise, you could use pip install matplotlib in your command prompt. So let's start by importing some basic Python libraries. We will import numpy as np, import pandas as pd, and import matplotlib dot pyplot as plt. After this, we will run a one-line code matplotlib space inline. This last line %matplotlib inline is only for showing the plots in the Jupyter notebook. If you are using any other editors, you will need to use the code plt.show at the end of your plotting commands to have the figure popping up in another window. So let's create some data for plotting. So the data for plotting graph in Python could be a list, could be numpy arrays, or could be pandas data frames, it could be columns, series, anything. Here we will create two arrays for x and y. So we will use numpy.linspace. So this linspace will produce 11 number which would be equally distance between 0 and 5. So the parameters here are start, stop, and the numbers we want between start and stop. Both start and stop are inclusive here. So see, this returns evenly spaced numbers over a specified interval. So it will return 11 numbers between 0 and 5, including 0 and 5. So let's run this. So we have our array here from 0 to 5, and let our y be x raised to the power 2. So y would be square of all of these numbers in the x array. Next, we will create a simple line plot using functional method. Functional method is nothing but using matplotlib arguments as a function. So here we can use plt.plot, and let's check the doc string here. So we have our arguments, and then we have scale for x, scale for y, and data. This will plot y versus x as lines and or markers. So see, this is what we will pass in here. We will pass our x data for the x-axis, and then y, which will be data for the y-axis, and then we have this fmt. This fmt is an optional parameter. It is a convenient way for defining basic formatting like colors, markers, and line style. So this is an example of fmt. So basically it is a shortcut for defining the color of the line we want, the kind of line style we want, and the markers. So this r plus will basically produce a red line with this plus markers on the line. BO will produce blue color line. O is short for circle markers. So let's plot this. We will have x and y variable here for x-axis and y-axis, and then we will pass in R for red color. Or let's check this without the color first. So see, this produces a graph between x and y data, and this by default is given in blue. If we want to change the color, We can pass in our fmt argument here. Let's change this to red. R is short for red, and this will turn into red. Now right now the line style is continuous. If you want dash lines, you can pass in this, run this, and it will produce a dash line. We can also run dash dot line. Okay, so this becomes a marker. If you pass it this way, do it this way, and this will produce a dash dot line here. Now on this graph we can also put in a label for the x-axis, for y-axis, and a title here. So for that we have plt.x level, press tab, it will auto complete, and just pass in the x level here as a string. So x-axis level here. Similarly we can use y level, y-axis level here. Let me correct this. And then we have plt.title. Title goes here. So let's run this. We have our x-axis level here. Whatever the string you will pass here will show on the x-axis. The string you pass inside the y level method will show on the y-axis, and title will show here on the top of the graph. Now see something. I have this. I ran this set of codes and I got an output. If I run the same code and at the end of the code I use the code plt.show, this basically gives me the same graph, but here I don't get an output. So this basically prints the graph. This is very similar to your print command when we can print a string. For example, let's see, we have x here. Let's say x is a string. If you just run x, it will give you an output for that variable x. But if you print this x, it will not give you an output. It will print that string here. Similarly, using this plt.show will print the graph. It will not give you an output. If you are using Jupyter Notebook, we don't need to use plt.show. But if you are using any other editor, you will need to use this plt.show to see the graph, to have the graph popping up. In the Jupyter Notebook, we can directly run the codes and it will give you an output with the graph here. Now let's say you want to plot multiple plots on the same canvas using the functional method. For that, we have a subplot method in Matplotlib. You can use plt.subplot. So if you check the docstring, this has a few parameters. We have number of rows, number of columns, and an index parameter here. So what this produces is basically like a table of plots, table of graph. So you can pass in the number of rows that you want, the number of columns that you want, and then the index. Next we will plot on this. So what this will plot is, it will have one row, two columns, and we have selected the first slot here. We can plot our x and y, and let's say we will use the fmt parameter. We want a red line, which would be dash line. Next, so once again we have selected one rows, two columns, and this time we have selected the second axis and we will plot on that. This time we will plot y versus x, and let's use green color with star marker and a solid line. Let's run this. X and y must have the same first dimension but have shapes 1 and 11. Oh, I changed the x here. This x has a single element and y has 11 element. That is because I changed x here. So let me go back and run my x again. Now if I run this should work. Yes, so I have my x versus y plotted here. So this has one row and two columns. On the first subplot I have selected the first axis, which is at index 1. This is x versus y, and I have selected red color dashed lines. And for the second axis I have plotted y versus x now. So y goes from 0 to 25 while the x goes from 0 to 5 on this second axis. And this is in green color with star marker for each data point, and this is a solid line. So this is a very simple method of plotting graph in Python using Matplotlib between two different data sets. Next, we will move on to object-oriented method. The main idea behind using object-oriented method is to create figure objects, which is nothing but empty canvas, and then just call methods or attributes of that object. To begin with, we will create figure instance, and then we can add access to that figure and then begin plotting our data. This has essentially three steps involved. Create a figure object, which is, imagine that as an empty canvas, then add a set of axes to that figure and then plot on that axis. So it's a three-step process. So let's plot our x versus y using object oriented method. First, we will instantiate a figure object. This is very simple. Use plt.figure method. Next, we need to add a set of axes to this. So we will use this figure object. Then there is a method add underscore axis, and here we need to define the dimensions of our axis. We will pass in a list here. Let's say this will be 0.1, 0.1, 0.8, comma 0.8. So it has four data points. The first one is for the bottom left corner of the axis. This will be distance from the left. Next is distance from the bottom. This is width of the axis and this is height of the axis. All of these are between 0 and 1. These are the percentage of the canvas which you want to include within your axis. So let's run this and see what this gives. So here, let's see this bottom left corner of the axis. So let's see this bottom left corner of the axis. Imagine the empty canvas behind this axis. This point is 10% from the left. This is 10% from the bottom, and from there it takes 80% of the width of the canvas and 80% of the height of the canvas. Now that we have created our figure and added a set of axes to that, we are ready to plot on that axis. So we have our axis variable. Then we can use the plot function x comma y. So let's see what this gives. So as we have seen earlier, using plt.plot, this will do the same thing, but now we have our figure and we have added a set of axes to this. So this is now under our control. We can customize the elements of the axis or this graph, which we will see a little later how to do that. For now, let's add label on the x-axis, y-axis and title to this. We can use set underscore x label. So when we were using the functional method, we directly use plt.xlabel, plt.ylabel, plt.title. But under object oriented method, this is slightly different. You have to use the method set underscore xlabel, set underscore ylabel and set underscore title. X-axis label, axis dot set underscore y label, press tab, select y label, y-axis label, and then axis dot set underscore t, press tab, title goes here, and we have our graph here. It has a label on the x-axis, y-axis and a title as well. And if you wanted to customize the graph, you can use the fmt parameter here. Let's say I want a green graph with lowercase v markers and a dash line style. So here's our graph using the object oriented method. Now this code is obviously a little bit more complicated, but the advantage is that now we have full control of where the plot axes are placed, and we can easily add more than one axis to the figure. So under the functional method, when we wanted to plot more than one graph on the same canvas, we had to use subplots. But here you can create multiple axes on the same canvas. So the advantage is here we can insert the axis inside an existing set of axes as well. So let's see that. Let's create another figure using plt.figure. Then we will add a set of axes to it and we will call it axis 1. Take our figure object and then add underscore axis. This will be similar to our earlier figure 0.1, 0.1, 0.8, 0.8. Now we will add another set of axes to this same figure, which will be inserted inside this bigger axis. We will add a smaller axis. Add underscore axis. Now let's say this is 20% from the left, 50% from the bottom, and the width is 40% of the width of the canvas, and the height is 30% of the height of the canvas. Now let's run this code and see how this smaller axis, which is axis 2, is inserted inside this bigger axis. Now we can also move the position of this. This can also move out as well. It can actually be completely out of this axis as well. In that case, imagine a much bigger second canvas behind the first canvas there. So let's say it started from 90%, or let's say it started from 100% from the left. Then this will be completely outside the bigger axis or first axis. So we'll move it back to being 20% from the left. Now third step. So in the first step we instantiated a figure object. In the second step we added a set of axes. In this case we added two axes, and on the third step we will plot on this axis. So let's start by plotting on the first axis first. We'll plot our x versus y. Let's say I want this graph in blue color. Then we will give our x level, y level and title here. X level here, set underscore y level here, and this should be axis 1. The variable is axis 1 now, because we needed two different variables for calling two different axes. Set underscore title, axis 1 title here. Now let's run this. Here this graph is overlapping with the second axis, so we will reduce the width of the second axis a bit so there's no overlapping, and we will plot on our second axis as well. Let's plot y versus x here, and let's say I want this in red color. X level for axis 2, y level for axis 2, and axis 2 set underscore title. Let's say smaller axis. We'll change this to bigger axis. Bigger axis. Let's plot this. So now we have our graph. For the bigger axis we have x level, y level and title, and for the smaller graph we have our x level, y level and a smaller axis title here. So this is very useful if you want to plot multiple graph This object oriented method allows us to place this graph inside the axis of the bigger graph. So this helps us to do two different visualizations together in the same graph. Now just like the functional method, we can also plot multiple axes on the same canvas using object oriented method as well. So for that we have a method called subplots, which is different from subplot for the functional method. So here we will use tuple unpacking. Here we are naming two variables together using tuple unpacking technique, fig comma axis, and use plt.subplots. When you press tab, you will see for functional method we use this subplot method, which was used to create multiple axes on the same canvas. For the object oriented method we have subplots. Here you can pass in your number of rows, your number of columns, and there are other advanced parameters as well. If you want to take a look, you can look into those. Unlike the subplot method, we don't need to pass in the third argument, which was for selecting which axis we are going to plot into. So here we have only two parameters, n rows and n calls. This is for the number of rows and number of columns we want. So let's plot this. Let's check this. See here we have three rows, 1 2 3, and two columns. And if you see these numbers are overlapping with the graph, if you want to change this, we can use plt.tight layout, and this will automatically adjust the graph. Now let's change the number of rows here to 1 to keep it simple. Now we'll plot on this graph. So we have our figure object and then we have our axis, and here we can iterate through the axis using either indexing or using a for loop to plot on this graph. Let's just check our axis variable. So this is an array which have two elements which are axis here. This is the first axis, this is the second axis. So we can actually index through it. Because this is a numpy array, we can index the numpy array using numpy indexing technique. So index it for 0, that will return the first axis, and we can plot on that x comma y. So now we have our graph on the first axis. Similarly, we can index the second graph as well, and let's say we will plot y comma x here, and this one we will use red color with dashed lines. You can also set titles and labels. Set underscore title, first axis, set underscore x level, and then set underscore y level. Let me just copy paste the same thing, and here we will change the indexing for first, and this is second axis. Let's run this and see. Now we have got our x level, y level, as well as the title for the graph here. So using this we are able to plot multiple graphs on the same canvas using object oriented method. Now here we use the indexing to plot on this set of axes and added x level, y level, and title here. We can do this using a for loop as well for the object oriented subplots. So let's do that. Here we have our tuple unpacking, figure comma axis, and we will use plt dot subplots, and we will pass in 1 comma 2. This is first parameter for n rows, second parameter is for number of columns we want. Now here we can use a for loop to iterate through the axis here. For x in axis, x dot plot x comma y, let's say we want red color here, then x dot set x level, let's pass in just the x here, then set y label, pass in y here, then x dot set underscore title, and let's call this title. Let's run this. Axis object has no attribute title. Okay, spelling mistake. Now see how this y is overlapping with this graph here. To adjust that, we can pass either plt.titleAout or fig.titleAout. Remember, fig is variable here for this figure object, so it can be used to call this figure object. Let's say if I want to call this graph here, I can just type this fig and it will return this object. So to change that, we can use either plt.titleAout or fig.titleAout, and so this y will shift to the right and it will create some space between the two graphs. So here we saw two different ways of plotting a graph using Matplotlib. The first one was the simpler functional method where we used the plot function and plotted our x and y datasets. And then we added x label, y label and title to the graph, and we also played with the color of the graph, the markers and the line style. In the second method, which was the object oriented method, we instantiated a figure object, then added a set of axes to that figure and then plotted on that axis. Now the Matplotlib allows us to customize various aspects of the figure, so we will look into some of those now. So the first is figure size and DPI. Figure size is basically the size of the figure which you are plotting. You can adjust the size using this fig size parameter. We will pass a tuple for the width and height of the figure in inches. The next is DPI, which is basically dots per inch or pixels per inch. The normal is 100. You can just pass in a number if you want darker, more detailed figures, if you want more pixels per inch. So let's check this. While instantiating the figure object using plt.figure, we can pass in arguments for fixed size. Let's say we want 8 by 4 size figure, and we can pass in parameter for DPI, let's say 100. So this will create a figure with size this on with 0 axis, because we haven't added any axis here. We have just instantiated a figure object which is an empty canvas. We can also pass the same arguments to subplot as well. Let's say you want to add axis to this. X is equal to fig add underscore axis, and let's say we use 0 0 1 comma 1. So the bottom left corner is at the bottom left corner of the empty canvas, and the height and width of the axis is the entire height and width of the empty canvas here. And then let's plot on that x comma y. So this is our graph. This is 8 by 4 graph. We can change it. Let's say we want 5 by 4. So this will adjust the size of the graph. We can also make it really small, let's say 2 by 2 figure. So we can change the size and we can change the DPI as well. Let's say we pass in 200, so this will have more pixels per inch. So this will produce much more darker and more detailed graph. If we only pass DPI as 10, this is very small. So as you can see, DPI has much more impact than the fixed size. We'll go back to our normal DPI of 100. But this figure size is now too big, so let's say DPI 80 would be good for this. If you check the doc string for plt.figure, we have a number parameter, so you can basically assign a number to the figure and then you can call that figure using this number. So you don't have to instantiate an empty canvas every time. You can actually call this figure back. A number is a unique identifier for the figure. If a figure with that identifier already exists, this figure is made active and returned, so it will basically return that figure. Then we have fixed size argument, we have DPI argument, and then there are other parameters as well. We'll change it to 100 and we'll change this to 8 comma 4 here. So it produces this graph which is where the height is lesser than the width here. Now let's use this figure size parameter with subplots as well. Fig underscore axis is equal to plt dot subplots, and here we are not passing any rows or columns, so by default it will be 1 and 1. So there will be just one row, one column, so there will be just one set of axes here. We will just pass in the figure size parameter. Let's say it will be 12 comma 3, so the width would be 4 times the height. Then let's plot on this axis x comma y, and let's say we want the red color here. So see how the width is much more than the height. If you want to adjust this, if we use 4 comma 3, the graph itself is much more smaller. If you want to elongate this, we can use 12 comma 3. Now that we have created this figure, let's say you want to save this figure for future reference. Figure objects can be saved in different formats, all of the different available formats like PNG, JPG, JPEG, PDF, everything. Just call this figure and use save fig method. And if you check the docstring, we need to pass in a file name here. So you can pass in your file name, and you can use .png or .jpeg. Python is smart enough to understand the difference and will download the figure with that name itself. And this figure image will get downloaded to the same folder in which you have your Jupyter notebook. So next, let's move to adding legends to our graph. To add a legend, we need to add a keyword argument label is equal to label text when plotting the graph, and then use the legend method. Let's see this by plotting a graph. We will use the object oriented method. Figure is plt.figure. Next, we will add a set of axes to this figure. Add underscore axis. Let's say the coordinates would be 0, 0, 1, 1. So the bottom left corner of the axis starts at the bottom left corner of the empty canvas, and the width and height of the axis is same as width and height of the empty canvas. Now let's plot. We will use x, and on the y-axis we will use x raised to the power of 2, and we will pass in a label parameter here. We will pass in a string, and that string will be x raised to the power of 2. Now let's plot another graph on the same axis. This time on the x we have x, and on the y-axis we have x raised to the power of 3 to show different labels. Now for the label we will pass in the string x raised to the power of 3. Now let's plot this. Let me pass in a figure size as well. Let's say this will be 5 comma 4. So here we have two different lines. We know one is for the first plot, the other is for the second plot, but we don't know which one is which. We have two different colors, one blue and one orange, but we don't know the difference between them. So what you could do here is add in a legend using the legend method, and then run this. This will use these labels here and will add a legend using those string to this graph. So now it's clear that the blue line is for x raised to the power of 2, and the orange line is for x raised to the power of 3. Now if you are mathematically smart, you would be able to say the difference between the two just by looking at it, because anything raised to the power of 3 would be more than anything raised to the power of 4. So x square would be 16, x cube would be 64. But for other graph you may not be able to say the difference between different lines. All graph may not be such straightforward, so legends are very helpful in that case. Now we can also move the location of this legend. Let's recall our figure. This is our figure. So in the legend command, if you check the docstring, we have certain arguments here. If you check, the first one is LOC, which is short for location. You can either pass in a string or a floating number. Here we have string called upper left. This is for locating the legend at the upper left corner of the axis. Then we have upper right, lower left, lower right. Then there's upper center, lower center, center left, center right. And then we have center, that would be middle of the axis. And then we have a string called best, which will let Python automatically decide where to place the legend so that it doesn't overlap with the graph. Now for this options, we also have numerical codes here. So if you add the location 0, it will be best. If you add 1, it will be upper right corner, so on and so forth till we have location 10. So you can try all of these and check for yourself. Then we have another parameter, bbox to anchor. For this we can pass in a tuple. So if you only use the location, the legend would be placed only inside the axis. If you want your legend to be outside the main axis, then we can use bbox to anchor. Bbox to anchor will basically position the lower left corner of the legend box to the coordinates you pass in using the tuple. So inside the legend command, we can pass in a location and we can pass in bbox to anchor, either using a 4 tuple or a 2 tuple. Most common is 2 tuple, like this. Here the location is given as upper right and bbox to anchor is given as 0.5 0.5. So basically 0.5 would be 50% from the left, 50% from the right. So it will drop an anchor at the middle of the canvas, and then the location will be decided based on that anchor. So for different locations, the legend will move around that anchor, whether you want it to be upper left, upper right, lower left, lower right, or center on that anchor point. So here let's check this. First location is equal to 0. This allows Python to automatically select the best location, and Python has decided that your upper left corner is the best option right now. Let's check for location is equal to 1. 1 is for upper right, 2 is for upper left, 3 is for bottom left, 4 is for bottom right, 5 is for center right, 6 is for center left, 7 is also giving the center right option. Let's check for 8, that is center down, 9 is center up, and 10 is right in the middle of the axis. If you go to 11, this should return an error. The location must be string, coordinate tuple, or an integer 0 to 10, not 11. So we can also pass in a coordinate tuple here. Let's try 0, 1. So this is at the, and these are in percentage. So these numbers vary between 0 and 1. It could be a fraction. If you are using 0.5, that means 50% from the left or 50% distance from the bottom. For this bottom left corner of the legend box. So this is 0% from the left, distance from the left is 0, and 100% from the bottom. If you would rather move this legend to this location, we can use 1 here, and let's say distance from the bottom could be 0.8, that is 80% from the bottom. And see, the legend has moved here. You can adjust it, better using the locations. However, the better way of doing this is using bbox to anchor. I will copy this. So this will drop an anchor at the middle of the canvas. Let's run this. Now let's use this with location 0. So see how this will revolve around this point. 1, 3, 4. You can see how this is revolving around an anchor point here. So this is the anchor point right now. Depending on the location you give now, it will revolve around that middle point. Let's try 8. Let's try 9. Let's try 10. So it will be revolving around this point. However, if you want to place it outside, we can use 1 here and let's say 0.9, and now it will be outside. We will not use 10, let's use 5. Okay, this is inside now. 5, 6, this is just outside. This is perfect. Next, we will move on to setting colors, line width and line style. So using the FMT parameter, we have already seen how to quickly set the color, marker and line style. Uh, but we will talk about those in more detail using the parameter for these. Let's take another look at the FMT method we used earlier. We will use subplots. Fig comma x is equal to plt dot subplots, and then we will plot on this x axis, let's say x, and on the y axis x raised to the power of 2. And using FMT method, we will use blue color dash line, and we will add another plot to this x, and then x raised to 3 on the y axis, and then this will be green, and then we will use this dot marker and solid line. So this has added another solid line with dot markers. Remember, if you change this dot after the line, this becomes the line style, that is dash dot. So this is a line style, there are no markers on this line. Under the FMT method, first you have to use the color, then the marker, and then the line style. If you want dash dot line, you can use this way. So this is the color, this is marker, and this is the line style. Here we will use a solid line. So this was our quick method. Now let's see this color, markers and line style in more detail. We can also define colors by their name or RGB hex code. So earlier we use alphabet for the color, but when you are using the color parameter, you can also call the color by their names or RGB hex code, and we can provide an alpha parameter as well, which can increase or reduce the darkness of the line. Basically, it indicates the opacity of the line. So let's plot this. Fig comma x is equal to plt dot subplots, then x dot plot, let's say x, and on the y axis we will have x plus 1. Next we will use the color parameter, and we will pass in a color blue as string. So let's plot this. This will plot a straight line. For every value of x, the y is x plus 1. So for 1 it will be 2, for 4 it will be 5. Here, now let's say you want to vary the darkness of this line. We can pass in an alpha parameter. Let's say we will use 0.5. So the color becomes lighter here. If we use alpha is equal to 2, it will become darker. Nope. Alpha is outside, so the range of the alpha is between 0 and 1. So let's pass in alpha is equal to 1. And so this is the darkest we can have. This is basically the opacity, so it's in percentage 0 to 1. Let's say we will pass in 0.1. It will be very light here. Let's pass in 0.3. X dot plot. Next we'll use x plus 2. We will add another line to the same graph. And for color, so let's plot another color. Next, x dot plot. Now this time let's use RGB hex code for the color name. You can find the RGB hex code using Google for any color you would like. I will copy paste one from Google, and this is for purple. Let me use another one. And now it will plot green. and this is for orange. So you get a feel of how to use different colors or change colors on your graph. Now let's move on to different line styles, line markers, line width, and some other useful parameters we can adjust. So let's plot this using subplots. Axis comma fig is equal to plt dot subplots. When we do not enter any parameters here, it automatically assumes the number of rows and columns each to be 1. So there's only one row and one column in the subplots. And then we plot on this axis. Let's say x, and on the y-axis we will have x plus 1. And for color we will have color red. And the first parameter I want to show you is, so you have already seen how to change the color of the line. You can also change the width of the line as well. So let's start with 0.25, which would be a thin line. This is a very thin line. Now let me copy paste this code. And line width now would be 0.5. So you see the difference between these two options. This red here looks more pinkish for some reason. Maybe if we increase the line width, it will become more reddish. See, as the width of the line increases, it's becoming more and more reddish from pink. And if we use line width 1, this is now proper red. So this was about line width. Let's plot another one. For the same red color, and now in place of line width we can pass in a shorthand parameter lw, and we will pass in the line width is equal to 2 now. So see, this line is thicker, and this lw is a shorthand method for the line width parameter. Now next we have different line styles, which we have seen earlier as well. So let's continue with the same plot. X comma x plus 6. Color would be, let's go for green now. We have line width is equal to, let's go with 2. And we have line style. Let's go for solid line. So this is green color, the line width is true, and this is a solid line. Now let's quickly plot different kind of line styles. 7, 8. So this line should be one above the other. So we have a dash line, we have a dash dot line, and we have a dotted line. So this is x plus 6, the solid line. For the dash line we have this x plus 7 line. This is dash dot line, and this is dotted line. And in place of line style, we can use this shorthand method as ls here. In place of line style, we can use the shorthand method ls here. This should work just as fine. Now let's check for different markers here on the line. Our plot x, we have x plus 10. Let's say the color now would be blue. We will go for line width is equal to 2. Let's say line style will be solid. And for marker, we have a marker parameter, and we have few different markers available. You can just run it without the marker and it should return an error of some form. It didn't, so it's just a blank marker. Let me use this. Yeah, this will show an error, unrecognized marker type. You can use lowercase o for circle markers. There are few different kinds of markers. You can Google and check this. Some basic ones are plus, lowercase o for circle, star mark, s, comma, dot, and you have numbers 1, 2, 3, 4. So let's try those. Let's try some of these. 13, 14, 11, 12, 13, 14. We'll keep the color blue, line width to line style same. And for markers, to show you the difference, we have plus, we have lowercase v for triangle markers, we have s, and we have number 1. And all of these will produce different kinds of marker here. So o, lowercase o is for circle, then we have plus markers, we have lowercase v for these triangle markers, we have s for square, then we have number. And you have different numbers as well, which produces different kinds of markers. The numbers have different thickness. Next we have marker size and color. So you can not only adjust the color of the line and width of the line, we can also adjust the size and color of this markers itself. Let's use a different color. Let's use purple now. Same line style, same line width. Because we want to focus on markers, let's take a circle marker so it will be easier to understand. And now we will vary our marker size. So we want to plot bigger markers, we can vary the size. Let's use 2. The size is very small for the circle. Now let's copy this. Let's say we will vary the size. We'll go to 4, we will go to 8, and then let's try for a different square marker as well of the same size, 8, and see how the size. No, I forgot to change the number here. Now see on this purple lines, the first one I had marker size of 2, 4, 8. So this was 2, 4, 8, and this is the same size square markers. Now we can change the color of this as well. We're plotting all of these lines on the same graph so that you can easily see the difference between all of these. We can add in a marker face color parameter. Let's say we want this color to be red, and you can see the difference. Now when you see the red, you see a boundary line across that square as well, and you can get this with circle as well. There is a black square, black boundary line. We can change that. Let's plot this again. Let's add another line, same color, same line width, same line style, same marker, circle, marker size, marker face color. Now we can add more arguments, marker edge color. Let's say we want this outside boundary line to be yellow in color. You see how the outside boundary has become yellow. We can adjust the width of that boundary line as well. Marker edge width. Just like we have line width, we have marker edge width parameter as well. And let's say we go with 5. This will be really big boundary lines. And you see the boundary lines have become so big that the actual face of the marker has become very small. It's behind the boundary line. So let's reduce the width. This looks better. You can change, let's change this color yellow to green. Let's change this marker to square, and it looks different. So here you can see all of this variation. We changed the color, we used the alpha argument as well to reduce or increase the opacity of the color. Then we saw different line styles, we saw different line width, line style, use of different markers. Then if you want even more customization, you can adjust the color of the markers, then the color of the marker edge and the width of the marker edge as well. However, keep it simple. All of these details are good to know, but when you are actually plotting this, keep your graph simple. You don't need to go into so much of detail, but if you do need, then you know how to do it. So one last one, we will see how to adjust the range of the plot. So we can configure the ranges of the axis using set underscore ylim and set underscore xlim methods in the axis object. So let's plot our figure once more. It's equal to fig comma x is equal to plt dot subplots. Here we will plot one row and two columns to show the difference between different axis ranges. And let's use the figure size 8,4, or we can change it to 12,4. So now let's index through this. Let's plot two graphs on this, x raised to the power of 2, and then we will plot another graph using the same plot function, x raised to the power of 3, and we will do this for both of these axes. So we have the line x raised to the power 2 and x raised to the power of 3 lines. Now what you can do here is, if you see the starting point of axis does not coincide with the starting point of the lines, and the end point of axis on both right and on the top does not coincide with the ending point of the lines. So to adjust this range of x and y, or you want to look at this graph in much more detail in this range, on the x-axis you want between 1 and 3, and on the y-axis you want between 0 and 20. So what you can do here is, you can adjust set underscore xlim and pass in a list for the range you want. Pass in a list for the range you want on the x-axis and y-axis. So on the x-axis we want it to be between 1 and 3 and ax1 dot set underscore ylim. Pass in your list, we want it to be between 0 and let's say 30. Let's run this and see the x range has been adjusted between 1 and 3, and the y is adjusted between 0 and 30. So we are essentially seeing a zoom up version of this graph. And here, while this graph was curved, you can see the exact points, because this is not a continuous graph, so you will see this data points here. Basically, whenever you want to zoom in the graph at a certain level, you can check that. Even if you want to look at this part between 0 and 2, let's say, you can change it to 0 to 2, or we can further change it between 0 and 5. Now you can further study this portion between 0 and 2 in much more detail here. So see, the square of 1 and cube of 1 is the exact same thing 1, so both lines coincide at this point, but on the point 5 x square is actually larger than x cube. However, the moment it crosses 1, then x cube becomes larger than x square. So you cannot study that using this graph. You have to zoom into the graph, and you can use set underscore xlim and set underscore ylim to zoom into a range of x and y axis. So that's all for now for Matplotlib. So in today's video, we started by importing our libraries and creating a data set. Then we plotted some simple graph using functional method, saw how to create multiple plots on the same canvas. Then we moved on to the object-oriented method, which is a more formal way of plotting data using Matplotlib. We saw how to create multiple axes, one inside the other, and subplots using object-oriented method. Then we moved to adjusting other attributes such as figure size, DPI, colors, axis range, line width, line style, and marker styles, along with adding legends to the figure and saving that figure in different formats. Other than these simple line plots, Matplotlib can also be used for specialized plots such as bar plots, histograms, scatter plots, etc. But all these plots can easily be plotted using Seaborn, which is a statistical plotting library for Python, or Panda's own built-in visualization features using simple one-line codes. Panda's visualization features are used for quickly plotting simple line graph for our own analysis, while the Seaborn produces much more colorful and presentable graph. But in both these cases, it's important to know the basics of Matplotlib, as those libraries are built on top of Matplotlib, and hence Matplotlib arguments can be used with Seaborn and Pandas visualizations to customize those plots as well. So in the next video, we will move on to the Seaborn library. Until then, see ya. Thanks for watching.